Hi everybody, my name is Harsh and my project partner is Divyamani. Our project is the design and verification of NAND flash controller. So basically memory controller is used to ensure the proper communication between CPU device or memory like RAM or NAND flash memory. Previously memory controller were not integrated on IC circuits, but now in present days to enhance the performance, it is directly integrated in the IC. Usually, memory controller have been installed like error detection or SSD to NVMe controller to improve performance. NAND flash controller can manage multiple NAND flash memory at a single time. Now, moving on to design. In NAND flash memory controller, this is the basically outer structure of the NAND flash controller, and this is the internal structure of the NAND flash memory controller. In NAND memory controller, command data address flows through 8 input-output ports like a rising of edge of V any signal or input-output data is stored. Address get latched when AL is high and CL is low, and command gets latched when AL is low and CL is high. Data is delivered at rising edge of RNE and when C is low. You can see all the signals below in this block diagram. Now moving on to the internal structure of the NAND flash memory controller. This is the internal structure as I mentioned previously. This is the internal structure of the NAND flash memory controller. So NAND flash controller have two FSM. One is timing and the main FSM. The main FSM state machine interrupts the directives from the host, while the timing FSM is responsible for generating critical control signals. For data management, it has a buffer module which has dual RAM controlled by the main FSM. Other block is address counter. Uh, Error block is address counter for the data buffer control signal and ECC generator for error control. For error correction. The design supports operation like erase, program page, read page, or reset or read ID. In the page program, the read operation data is transferred between host and NAND flash memory when with ECC generation and detection for the error management. Throughout all these operations, state machine collaborates with the timing FSM block to ensure proper timing compliances. Now moving forward to verification.
Uh, Thank you, Hers. So the design which was explained by my teammate verified using this zone test bench, uh, with the help of which we generated different sequences, different stimuli using the sequences and driven to the DOT. And same we captured to monitor like comparing and doing coverage matrix to the uh, scoreboard and the subscriber. So in order to verify in the data flow, we also attach this flash interface so that our supporting commands can verify correctly. Now, if you see in the result sections, there are different commands are shown like block erase, programming, and read commands. So if you take one of the commands like programming, for that we have to initiate the command first, then our design internally divide it into the sub commands, which which will be followed by then the addresses, data, and then we can perform the ECC writing in order to check the in order to sure that about the error part. So ECC is nothing but the 7/4 Hamming code, and yeah. So after this, then finally we'll get the NFC done signal high, which indicates that our command has completed successfully. Now, if we move on to here the our coverage score, this represents the feature, uh, like how many parts or the percentage of feature we have able to cover till now, and so we are able to achieve 88%. In future, we can continue. And this project not only motivated us, this project not only introduced us about the NAND flash technology, but also also motivated us to explore more about this technology. So maybe we can focus on like how to improve uh, the technology in order to reduce the wear labeling of the sales of NAND flash. So I think that's all from our side, and hope you like this presentation.